Hello everyone and welcome back. Today is day 4 of Machine Learning Bootcamp organized by GIRLSCRIPT Chandigarh. Our mentor for the session is ANUSTUP Mukherjee. Currently he is a computer vision engineer at Dark Horse. He's a former lead AI engineer at Omdena. He is a former researcher at IIT Bombay and IIT Patna. So without taking much of your time, let's get started. Hello sir, how are you?
Yeah, hi, I'm fine. I'm fine. Okay, so yeah, so I guess we can start now, right? And as if there is no such previous questions from
No,
yesterday's sessions, yeah,
yes, there are no previous questions. Back from the students.
yeah. So as there is no such previous question, we can jump into the topics, right? And if anyone have any such kind of things, they can just post it up, right? They can post it up if any before the session if they want to know anything.
Yeah, guys, if you have any, them up the comment at the beginning of the session.
Okay. So today, before starting today's session, just I want to recap what we have learned yesterday and day before yesterday and before of that. So in the last 3 days specifically, so we have covered some machine learning algorithms, including linear regression, logistic regression, k-nearest neighbors, SVM, principal component analysis, and decision tree. We have not implemented all, but yeah, we know the complete logic how to implement them. What we have implemented, we have implemented the things like decision tree classifier. We have implemented decision tree classifiers in a weather prediction app. That was our previous project. And we know how to implement KNN on a segmentation problem. That is the camera problem I yesterday I told about. Right. Apart from this, we implemented some very good projects out of OpenCV. So we know how to handle the majority kind of complex cases by using the power of OpenCV. So we have a very basic idea out of this session about OpenCV. So what we have implemented in our projects in an OpenCV is something like image cartoonizer, a script of image cartoonizer, cartoonizing an image. Another thing that we have implemented is yeah, yesterday we had implemented pose estimation by the help of the OpenCV, and apart from that, number recognition as well as the digit recognition from a proper frame video that we have implemented yesterday. So till now we have implemented 4 good projects. So yeah, and also the weather prediction app was a very full stack app, and we are clear with them how to deal and where to deal, which kind of algorithm will be suited and which cannot be suited. This kind of things we know about how to work and implement machine learning. Right. So I will be not extending today's session a lot because already you guys have stored so much of things in your mind. Right. So like if I store more, then obviously it will be getting burst out if you are a beginner, taking from a beginner's aspect. So again, yeah, I will be covering a basic concept of deep learning today. What is deep learning, how to proceed with deep learning, what things you need to know out of deep learning, and very basic implementation of CNN, convolutional neural network, right? And how can you always proceed in deep learning, what are the important steps out of it. So today's session is all about deep, and tomorrow we will be having career guideline and complete ending session from tomorrow, right? So yes, again asking if anyone have any sort of doubt, they can ask right now as per the previous session. So we will be ending the machine learning part. Now let me share my screen. We will be starting with the deep. Very basic idea of the deep. Yeah. So let us start with the concept and implementation of deep learning. So at a very initial moment, everyone's mind must be asking this kind of question: what do you mean by deep learning? Right. So this kind of question is something like this. It is again I'm repeating the same line again. Machine and deep is nothing different. It's all same. Entire kind of learning, whether you are coming to machine learning, whether you are coming to deep learning, whether you are coming to generative learning, each and every kinds of thing are very same or same to each other. Or you might tell deep learning is a subset of machine learning, like that. Okay, so yes, so this is a very important thing that you need to take care of in your mind at a very starting. Now, question comes: what do you mean by deep learning in a very layman's language, right? What do you mean by deep learning in a layman's language, or if I come across you like to make you understand deep learning? Then, for that to understand that, we need to first cover the concept of human brain again. So again, I am coming to a very basic example. This is an object, not visible. Yeah. Now, okay, this is an object and this is you, and you are seeing the object by your eyes. This is your eye, right? So when you are seeing this particular object through your brain or through your eye, you are simply seeing the particular object through your eye. That is, you are seeing it. So that data will be traversed by your eye, or from your eye to the object to your eye first. I guess everyone know eye contains a nerve that is called as an optic nerve. That optic nerve specifically carries the data to the human brain, right? This is the human brain. So it is, the data is simply carried from the eye to the human brain. Now suppose this part of the human brain is, though it is cerebellum, but yeah, let us consider cerebellum is not considered for a detection, it is for motor movements, but yeah, cerebrum is actually involved. Otherwise, okay, let us consider this part of the human brain is mostly important for image processing. For an example, this part of the human brain process what we see. So how this data will move from the eye to this part? Because until and unless data reaches this part, there will be no processing, there will be no understanding, there will be no output in your mouth, that is, this object is that and this object is not that. Then how this will cover? I guess everyone knows the human brain is made up of by the neurons. That is, one neuron, suppose this is a neuron, and one neuron is connected with another neuron, right? By means of a connection is called synapse, right? So what happens, the data comes at this point and goes to the travels to the next neuron at this point. So this specifically what is an interconnected neural architecture. So what happens, the same thing happens on the brain also. So from the optic nerve, the data will be, by this, the help of this interconnected neural architecture, will reach to the part of the brain. Suppose this part of the brain we are targeting. Here the processing will take place, and finally you will be having an output in your mouth, that this is an object called a square, or this is a block, anything like that. So this is the architecture that is happening every time in the case of an object detection. In the case of an object detection for our human brain. So the same thing actually artificial intelligence adopts. So before explaining the deep learning architecture, I want to give a very example why there is a need of the shift from machine to deep. Why there is a need of this birth of deep learning? Because whenever there is a new learning, or whenever there is a new architecture or a new structure, or suppose whenever there is a new model or algorithm, right? There is a very firm or slight difference in between model and algorithm. I'm not going to that level right now, but yeah, whenever a new thing is created, there might be some logics of behind this creation, right? There might be some logics behind this creation. For an example, why machine had shifted or changed its pattern to deep, and right now present days era is speaking about generative learning. So why there is a need of shift from deep to generative learning, from deep learning to GANs? Why there is a need of shift? So we need to know that kind of need of shift is specifically. So the need of shift is mostly and importantly is something like, suppose let us take an example of image processing. Image processing is yeah, in what happens in the case of an OpenCV, when if I go back to the again preliminary OpenCV. For an example, take an example of 5 years old baby. So at everyday morning, the baby wakes up and see the face of his father, right? Suppose the baby wakes up and see the face of his father. So there will be, after 5 days or after 10 days, you might see like the person or the little baby will be only and only recognizing its father. Suppose you are shifting it into anyone's arm, the baby will start crying. The baby will start crying, right? How? Why? The reason comes why. So the reason is why, because the baby's brain is actually using supervised learning at its backend, right? Supervised learning at its backend. So why I'm telling the supervised learning? Because it is confiscated to a set of data. It cannot understand the change. It cannot understand like, okay, this is also a human. This person is not harming me as if the person whom I used to wake up in the morning and see, the person was also a human, my father, and the person whom to whom's arm I am right now given, this person is also a human, and this person is not gonna harm me. So this kind of code level detection a human's baby's brain cannot do, right? So that is the actual case that happens for the machine learning aspects, or what is happening in a machine learning case. For an example, if you are coming from a very OpenCV background, so very we are picking up an example of OpenCV, and you are trying to do image detection or image recognition, or for an example, facial recognition by using OpenCV, then what will be your very basic output, or what will be your very basic strategy? So your very basic strategy again is to extract the coordinates of each and every attributes present over the face. Again, the attribute is the nose. Again, the attribute is the lips. Again, the attributes is the eyebrows. Right. You have to extract out its particular and particular coordinates. You will be calculating the distances in order to analyze its each and every single feature. You might do heat map analysis. You might do RGB analysis. You might do this kind of things, color analysis. You might extract the threshold value of each and every colors present over it. You might mask to understand the persistence of any object over it. You might do any approach, like from color approach to from light approach, from coordinate approach you can do, and it will be only and only be applicable for a single image. OpenCV will be only and only basic OpenCV approach for a single image or a single video. So what does this means? This means is a very confiscated thing, or is a very bounded thing. That's this, that whatever we are writing, whatever algorithm or whatever strategy we are following, that is specifically bounded to a particular and a particular type of face and image, right? So now, obviously, human brain doesn't want to stop in a single sentence or a single point. Now they thought like, can AI detect anything? That is, if there is a new face, AI will have the power of to detection of that. Because if the AI doesn't have the power of that, then it is not the future, because it is nothing actually in front of human intelligence. So on that particular point, deep learning comes into existence, right? There are many theories, there are many mathematical abbreviations, there are many papers. I'm not coming to that. If anyone is interested, they might study all kinds of things. But yeah, it's a very basic idea or a very basic understanding why deep learning comes into existence. Now, theoretically, if anyone wants to know, then it's specifically advanced models, advanced computations, advanced feature extraction, this kind of things comes into explanation. But yeah, again, at a very important logic, this is the reason of the birth of deep learning, right? So now the question comes like, so how the deep learning models works, or how the deep learning model basically functions. Specifically, if you know, deep learning is again deep learning is not only in the computer vision part, it is also present on detection, it is also present on prediction, it is also present on classification. Everywhere it is present, right? So deep learning is present everywhere, right? So now the question comes, how a very basic deep learning model works, or how you have to proceed with a very basic deep learning model. For that, for an example, you are working on a very basic script of code. That is, suppose let us take an example of a weather prediction system, right? You are working on a weather prediction system. So what is this weather prediction system specifically, and specifically all about, or something? Let us take an example of any other thing. Suppose you are like, pick up an example of LinkedIn. What happens in LinkedIn? LinkedIn uses AI at its backend, right? So what happens in LinkedIn, or nowadays professional networking systems, they are using the power of artificial intelligence to give you similar profiles based on your proper job searches, or based on your present profile, or based on your interests, right? So if it is a machine learning approach, then how we will be thinking? That means I am your recruiter, and I told you to code up an algorithm or to create a machine learning model that will be showing you similar users. So when I am telling someone to show someone some kind of similar users or similar type of profiles, this thing that comes in my mind, okay, it is something related to dating algorithms, right? Yeah, it's obviously quote unquote dating algorithms, right? So the first thing that comes into mind, in your mind or everyone's mind, that is, we need to work on a matchmaking model. We need to work on a model that will be doing some sort of match. Now the question comes, what do you mean by a match? Match is again similarity. and similarity is again some kind of features, and features is again which kind, how much amount of the features are common in between A and B, right? Because when there will be match, then there, then obviously there might be a similarity. It's a general axiom. If you are matching with someone, there might be some kind of similarity to you and that particular person, and a particular person's obviously, and the similarity is not a hypothetical concept. Similarity again, maybe you are having some kind of attributes and that person is also having that same attribute, so this is a similarity in between two, and that creates a perfect match, right? So this is a very basic logic. So based on this logic, you have picked up a data set, from internet, right? So maybe it is a CSV data that contains some data of previous profile. Suppose there is a column in CSV, name of an employee, job title, age, present job title, previous job title, etc., etc. The columns of that particular CSV data is having that model. So now you are trying to show the user some kind of class, some kind of similar profiles. When you're up to showing some kind of similar profiles, then the first thing that comes into your mind, okay, it is a multi-parametric approach, because here only a single parameter cannot define the similarity. Because if it is, then it is a very dummy model. So you have to take reference from several parameters, maybe the user's location, maybe the user's gender, maybe the user's job profile, previous experiences, etc., etc., and etc. This is a very thing. This is a very parameterized approach. So yeah, for that you thought, okay, multi-parameterized approach I learned from the session is something decision tree classifier, right? Because it was also working well with a weather classification model or a weather prediction system. So you have simply picked up a decision tree classifier and you have simply trained your data on it, right? And now you are trying to predict. Now you are trying to say what will be the most top 10 similar profiles to my match, right? So now you have, what you did, you have inputted some kind of words which is appearing very less amount at your database, or suppose it is nothing there. Suppose your input feature is age, job, location, previous experience. Out of these 5 inputs, maybe 2 inputs are matching to your DB and rest 3 are unknown. So you will be seeing your model will be failing for the prediction. Your model cannot predict the output, or model will be showing some kind of random outputs, because the model is simply doing what? Model is training on the DB. That means whatever data being present over it, it is simply reading it, storing it, and showing in your output. So it is a power of machine learning. So now the question comes in your mind, how can I advance this thing? So here comes the predominance of any deep learning model. This is how comes in the predominance of in a deep learning model. I will be showing another machine learning model for this particular example. A model used to exist, but though it comes under NLP, but right now I'm speaking about deep learning, so only deep learning. So how deep learning will be solving this problem? So for that, we need to understand how the deep learning model used to work, right? So again, it is your input data. Idea I am writing for any kind of input data. So this particular input data is specifically whatever DB you are having at your backend. That means you are storing any data at your background. That means whatever data I have told, like about the profile, job profiles, etc., as well as the previous user's experience. So that data you are having at your background, and right now you have that kind of data as your training data, or something called as an input data. So now the question that comes in your mind, okay, I have my input data, you have performed some kind of like, I have done with some kind of exploratory data analysis. And when I am done with that kind of exploratory data analysis, you are done with understanding your data. So when you are done with understanding your data, now you have to proceed with the feature extraction part, because you have to know what kind of parameters being present on my data. So here, can you do some kind of advanced feature extraction? Now, what do you mean by advanced feature extraction? It's something about when you are meeting any stranger, right? I'm not getting the thing so much complex. I will be only speaking the basic things, because I know deep learning many at a very single flow it is very difficult to understand. But yeah, I will be giving some real life examples. So what do you mean by just I am giving just remember what kind of example I am discussing. I'm discussing an example of a professional networking system. That professional networking system will be showing you top 10 simply top 10 similar profiles out of your profile inputs, right? So it is a problem or project that we want to create. So I have done with collection of the data. Now what I will be doing specifically, so the first thing that I need to count in my mind is, suppose if there is any external input, that means suppose again there is 5 inputs and out of which 4 is very unknown or pretty unknown to me, right? Pretty unknown inputs. So what will happen? Can my model give a good prediction? That is a very question to your mind. So you have to again get back to your brain. Why get back to your brain? You have to think, understand, like suppose when you don't know any word, you don't know any word, a word you don't ever heard in your life. So what you used to do, you used to, at a very first, suppose you don't have any access to internet or you don't have a dictionary in your hand. So what you can do, you can simply relate the word. That means what we do is to relate the situation. Suppose we are coming across a new situation, or suppose you are in a difficult situation at your life, then how you try to solve that particular difficult situation of your life? Our elders used to tell, take just learn from the past. So what does this term or what does this thing that is being defined by your elders, learn from the past? It is nothing, it is a relative approach. Relative approach, like why relative approach? Because learning from the past is same thing about learning from a trained data, or like working on a trained data. That means now how it will be helping me, because my input is very new to me. Learning from a past is not only just what I have learned and I will be remaining or sticking to that only. It is simply relating the concepts. That means something like whenever we get a uncommon question in our examination, so how can you solve the question? You think what is the nearest possibility of the answers by some relative questions to that particular thing. So that is again relating in between other topics, or relating in between each and every topics, you will be getting an answer. Okay. So this is the most important thing. So relation, you have to create a relation. So if your features have some sort of relations in between it, or if you can extract a relation in between your features, or most important, and you can understand which is the most important feature, which is not so much important, which is most relational feature, this kind of things, then I guess if there is a new input or if there is some new inputs, your model will work. And that is a very basic point where a deep learning comes into existence, or a very basic hypothesis where a deep learning work. So how does this work? In the very stage of the feature extraction, you're done with the EDA part. Now you're done with the feature extraction part. So what do you do in this feature extraction stage? There are many told processes. There are many told hypotheses. Suppose for feature extraction for an image is having several techniques, several algorithms, several techniques. For example, you are using a image processing algorithm called as an MACR. Right? It's a Matlock's algorithm. It uses the power of segmentation. Suppose you are using another image processing algorithm that works on a region, finding the region of interest, etc., etc. Several algorithms. Just I will be speaking about our problem only. So in our problem, what we need to calculate? We need to calculate the similarity index. Right? So what is the similarity in between the most important features? So I guess you guys can remember whatever example I have cited some days before, is like if you need to calculate the example or calculate the most similarity in between the two features, how, like the predefined mathematical formula that it uses is something like a dot product, but I am not going to that kind of thing, or I am not going to any sort of computation, just I am explaining the problem. So here, what kind of approach we will be following? We will be calculating the similarity between two features, right? So the process of calculating the similarity is simply considering A as a vector, B as a vector, and finding the dot product of them. Whatever value it is returning, it is a similarity index in between them. This is the very basic line you have to do for calculating the similarity index for a basic artificial neural network. But yeah, there are many other proposed approach. So now the question might be coming at your mind, then how can we understand what might be our logic? Suppose I am dealing with a very new problem, and I don't know what is the logic of this feature extraction. Suppose for an example, I am giving a very of my example, just a little experience sharing. When I was working at IIT Patna's project, right? So my project was like predicting like upcoming like what will be the next or most upcoming cyber attack and what will be its extent. That means the people like you are working at that level, obviously we even cannot detect whether there is a cyber attack or not. And at that condition, I am telling what will be the next probable attack. The time, I am predicting a time. Or I am telling what will be the extent. That means I can't able to understand my present and I am speaking about the future. That means tell me in future if there is a cyber attack, at what extent it will be hampering me. This was the very baseline work. There were many extensions of the work, but this is a very baseline. How I solve this problem, because this kind of solutions is not even available over internet as if. So we simply did what for the feature extraction part, because we don't have any don't have anything that is like don't have any cooked product at the market or a cooked logic which we can fetch. So what we did, we took some systems, like we took like we used to work on a lab, we used to work on a lab and we used to have a collection of 4 to 5 systems. Like so we used to keep a data tracking. Data tracking means we used to do these things manually. Manually means like just a simple notebook, and we used to choose a very basic malware. That was a simple. I cannot recall the name which malware we used, but yeah, we choose the very basic malware, and we keep on. We simply the first thing we interconnected each and every PC, and we keep on affecting a single PC after a certain amount of the day. So what we understood, we manually noted down each and every possibilities of the cyber attack, or each and every timestamps of like first PC affected for a timestamp of T1, second PC affected at a timestamp of T2. This kind of thing we did, some kind of time series analysis. So that we first manually did, calculated by using now when we had a complete set of data after 2 to 3 months, then we sorry, then we finally had some kind of understanding. Okay, this is the scenario that might be happening. Okay, on the basis of this scenario, we simply calculated a little bit of things by manually and simply forwarded the logic. So in this way you need to deal with deep learning. I'm not telling always if you are working any real life problem you have to handle with that. For an example, another example I'm giving, another example is like this project I have also worked. Is like suppose you are trying to, you are driving, or you are simply in a security department, you are working on a security systems, or suppose it is a very college project. That means detecting a reckless driver, it is your project. So detecting a reckless driver, suppose a person is doing reckless driving on a road, and you want to detect that particular person. So the very, so first obviously you can able to collect the data from internet. Then what is the next step? Before any kind of training, you need to write the logic of the training, or you need to write the logic of the feature extraction, which is the important step. In that step, you need, the first challenge you might be feeling is when a person is driving reckless, obviously the person is in speed, right? So whatever image in output I will be having will be simply a hazy image, or a simply a hazy number, right? Or a simply hazy something. So whatever image on which I have to do the detection is hazy. So this is a problem. Second problem might be the image is very small that our human eyes cannot read. Then how a computer vision or artificial intelligence might read. For an example, take these two probable problems in this model. So at an initial moment, what is your brain speaking about? Feature extraction, person detection. So you have to write a logic of person detection in the feature extraction stage, right? But these are the two complexities that you need to tackle up. So what you will be doing, you will be now going to internet and searching from several kind of things. Like you have to search like this. This is the problem breakdown. I am not giving you the solution. I am showing you how to deal with projects. Projects is not like completely I know to code, भाई आया code किया निकल गया, ऐसा नहीं होता. Okay, so projects is completely how you will be processing it in your brain. So how you'll be solving it. And if you have these skills, then no one can stop you. So this is the how, like you have to break down. Okay, I understood the very ground level problem. Ground level problem, I want to detect a reckless driver. Suppose the driver is drunken and doing reckless driving, I want to detect the thing. So my very basic logic in a feature extraction stage will be a person detection. So I need to use a deep learning model that is doing person detection. But there are some complexities in my case. What are the complexities? The number is, sorry, not number. The person image that I am extracting out of a real-time video is very small, that a human eye also cannot read it properly, and alongside whatever maybe I am trying to track the number plate of the car, the numbers also are very small, as well as the whenever I am getting the image, since the person is in a speed high fps, so specifically it is being coming something called as a hazy. The things are not clear, blurry. So you have now you have broken down your logic into three stages. The first stage you want to deal is completely like blurred image detection. So if there is a blurred image, so how can you detect the objects present on it? Go back to internet, you might search some kind of logic or some kind of features, get it down. Next thing is the small or short number detection. This kind of thing, when you are done with the problem breaking down, now you can get across two or three kind of training scripts or feature extraction scripts. Now you can note it down all, and now you can understand, okay, this kind of things I might do so that my logics will be solved. Input that things, input that kind of functions or logics in your feature extraction stage. It will be extracting you a set of features. Set of features means set of features of the person detection as well as for the number detection. So this is how we used to follow the problems. There are, because I am not speaking about, in there are processes also. I am not directly speaking about the mathematical concepts. Or if anyone might be interested, then just I am just telling some kind of concepts. Like for the mathematical concepts, you need to extract out each and every matrix. You have to work on the ground level or zero level matrix works. For a matrix functions or a matrix things, you need to work on, or suppose you're working on an image processing things, you need to work on segments as well as etc things. So I'm not going to mathematics because many of you might be feeling difficult, but this is the way we used to deal it. So now you are done with the extraction of the features. Now what is next? This is the most important stage of any deep learning model, and for which it is mostly remembered, training, the training stage. So in this training stage, I always already told it follows a neural network architecture, or not a neural network. It is simply a stage-wise training or a layer-wise training approach. So it is simply all about, suppose this is for the layer 1, layer 2, layer 3. Suppose I am doing 3-layer neural network. This is 1, this is 2, this is 3. Right, and these 3 layers obviously are interconnected. Mind my diagram just to show you. I am doing like this. Suppose it is that these 3 layers are interconnected to each other, right? So what does this happens, like what happens in between these 3 layers? So what happens in between these 3 layers? These 3 layers are simply some kind of parser? No, these 3 layers are not the passers only. These 3 layers doesn't pass the things like blindfoldedly. There is something happening in between the 3 layers. Something happening. What is this something happening? This something happening, again, come back to your real life. In your real life, suppose what happens actually, yeah, you're running. Simply you are running like in a pattern, like you have did something. Or let us take an example of a football ground. In a football ground, football players are playing. There are two teams, team A and team B, right? So the players of the team A are passing ball from one player to another player, and they doesn't want the team B to get the ball, because if team A have the ball, then there is a chance for their goal, and in our case there is a chance for very good output. So team A doesn't want team B to have the ball. So what does this team A used to do? They used to pass the ball from one player to another player. So whenever they are passing the ball, they are not passing the ball blindfoldedly. That means you are a striker and you need to pass the ball to you. You can pass the ball to directly goalkeeper. There is an option to pass the ball directly to the goal post. There is an option to pass the ball directly to a defender, or there is an option to pass the ball directly to a midfielder. There are several kind of options. You are a striker. You need to strike up the ball, right? So so there is some logic running in your mind where I will pass it. Obviously, the question is where I will pass it. So you think, okay, the team B guys are engulfing, or there are several team B guys around or surrounding that kind of people in that is who is present in Suppose the midfielder and a goalkeeper, not goalkeeper, midfielder and another striker is surrounded by some kind of team B guys. So if I shoot the ball on their side, then there might be a very fair chance that guys will be getting the ball. So your brain tells, okay, for now directly shoot the ball at the goal post, right? Shoot the ball at the goal post. So there is a chance that your brain is speaking right now. So there is some kind of computation happening in your brain. So the same thing happens in a deep learning layers also. Deep learning layers are not blind, like they're passing the data from one stage to another stage or one layer to another layer. What they're doing, there is some a logic called as an activation function, right? There are many logics, convolutional layer, ReLUs, many things. I will be coming to the theoretical concepts later on, right? So what does this layer actually do? And sometimes many people will be feeling this implementation of the layers are remembering things. No, they are not remembering. So what happens if you are working on a very basic project, that means image recognition by using the CNN, or if there are basic projects, then obviously we'll be doing the same code over and over again. But whenever you are going to implement good projects, or suppose working on good company, I used to know a work where we used to work on image auto completions, or I not one of my colleague used to work on image auto completions. So specifically on there, they need to break up the neural network. That means they have to write the logic for each and every layer at neural net. I used to work on educational LMS. There we also need to create the logics for each and every layer, or feed some logics at individual layers. So these are the things actually. So you need to understand how these layers are being performing at each and every stages. So how this layers is specifically performing, for a very basic example or from a layman's point of view, that means it is called as a feature processing. That means layer 1 is not going to pass the same feature the layer 1 is having. Layer 1 will be processing the feature and extracting out the most of the best of it, or what are the best extracted features that can be processed in the very next stage. Let's come to the layer 2. Layer 2 will be again repeating the same process and passing to the layer 3. This is the process that happening at its backend. Now why this kind of processing used to take place? So there is something called as activation function. So activation function, there are many things. There are activation function, back propagation, forward propagation. I'm telling about it. So first come to example of an activation function. Activation function is something like, I want to give an example of Super 30. So what is happening at Bihar Patna Super 30? So the Super 30 is a set of 30 that meritorious students. And if you are into Super 30 but you are not so much meritorious, you will be simply excluded out. So what is happening? But what is happening at it case, or what is happening, or what kind of deep learning algorithm happening at the mind of Anant Kumar? He is using the deep learning logic of activation function at its backend. His brain is using the logic of activation function. That means if you are not eligible for this post, or if you are not eligible for this role, or if you are not eligible for this kind of work, you will be excluded out. So most unimportant or disrespected features will be excluded out by this help of the function. Right. So now come to the next important stage. So this is a way that is being present on each and in between two layers, layer 1, layer 2, layer 2, layer 3, like that. So what is the more there? What is called as the, so okay, you have understood, okay, from layer 1 features extracted, important features passed to layer 2, same like layer 3. So how the computation gets more advanced? So I guess many of the people knows about that, or came across at least the term of back propagation or forward propagation, or FPP BPP networks, right? So what does this happen? Forward propagation is nothing what is happening right now. Forward propagation is nothing what is happening right now. The network is flowing with the training, right? Now the very next step is backward propagation. Why a model will be having a backward propagation? Why it will be again going back and dealing with the same thing? So backward propagation is a choice based work of a model. For an example, what happens in our case, whenever we do something wrong, or whenever we feel like this is wrong, we try to rectify it. Suppose you are simply doing a sum of ratio and proportion, when you are up to calculating the answer, you have find your answer is not coming correct. You are checking your backward steps, because whatever you have written before, based on that your answer is coming. Simply and simply your answer is coming. Okay, right? So this is the thing which is happening in our case. So if we can solve our problem, or if we can understand our problems and solve our drawbacks, then why not a deep learning model, right? It is very much computationally advanced. So the same thing is happening in the deep learning also by the help of backpropagation. If it is finding like whatever set of feature it is dealing all about, or whatever the output is coming, it have the power to go back, correct the most responsible feature, remove it out, and come again to the forward part to deal all about and to deal with, right? So this is the logic of backward propagation and of forward propagation. Now what are the other steps, the other most important steps? Another term that comes whenever you will be studying neural networks is the ReLU, rectified linear units, right? Rectified linear units. And what does this rectified linear units is all about? This ReLU is again something like, suppose you are having, for an example, what I have right now told is something like, you are having a certain kind of activation function. Yes, your activation function is happening, or your activation function is coming across your, or your meeting your need to remove the most unimportant or irresponsible products. For an example, take a real life or the real life example again, because these things are very mathematical. I want to just remove out the mathematics for this short term explanation, right? Again, if you want to go and break your own very big projects, just recover the backward things, because it will be helping you, something like this. So for an example, if you are again take an example of a class. In a class, there are a class of 50 students, again a class of 50 students. Out of the 50 students, there are 70 students are very good students, very good students. Now the rest 10 students. In this rest 10 students, the teacher found these 10 students are very disturbing, and just divide these 10 students into two parts, one 5 and 5, 5 is to 5. First 5 students is a normal bad student. That means they are really bad and they don't have any power. But the last 5 students are having power. That means maybe there are some students coming from any very big background. There are also some bad students and having big power. So teacher, which group of students the teacher will be removed first if they want, or easily can remove, is the first group of student, because the student is bad, having a genuine reason, and also if the teacher remove, the teacher will not get any kind of harm, right? Or there is no tension of the teacher, like okay, this person doesn't have any big power, so I, if I remove them, so there's not an issue. Or for an example, I guess the example is not so much clear to everyone. I guess everyone have watched Mirzapur, right? What happens in Mirzapur? What happened in Mirzapur, at a very scene one in Mirzapur's, you saw Munna Bhaiya is coming and entering in the room and doing that kind of tahandav, right? So teacher is standing there, but he is not telling Munna Bhaiya anything, because if the person is up to telling, then the on that time there will be another thing, right? So by default of this fear, the thing is not happening. So what kind of deep learning technology this director of Mirzapur have utilized? The deep learning technology the director of Mirzapur have been utilizing is the logic of rectified linear units. Really, he might be knowing deep learning. We know, every one of us know deep learning, right? We are using in our day-to-day life. We use entire AI in our daily life, but we don't know what is it. That's it. So why the teacher is not removing? There is a chance of harm. So just relate the concept in deep learning again. You are training a neural network, your layer is proceeding from one step to another step, like that. So in that case, what is happening? You are removing some unimportant features, because the features are not so much important. There are some, maybe they are external features, or maybe they are not so much important. But at the output end, you are finding, or at some layer you are finding, suppose you are dealing with an image processing value. Your image colors are extracted, and there are some colors which are going extremely out of bound. That means the actual color might be red, but it is showing it black. But when it is something inner feature, that means a feature which is representing some part of the color, or representing the some part of an image, if you are removing that, it might harm your training, it might harm your data, or it might harm your architecture. How a model tactfully analyze it, and how a model tactfully remove the most unimportant feature or most problematic feature. This is not unimportant, one of the important features but problematic, which is just hampering your output. Here the value comes into existence. Here you need to take the help from rectified linear unit, right? So here rectified linear units used to come into existence. I am again telling the mathematical formula: f max equal to the set of matrix of that kind of non-negative linear values, right? Non-negative linear values. So but don't go to the mathematics, just understand, because I don't want to mess up the things again. Yeah, it is really very difficult to teach this kind of things without the help of functions and maths. But yes, we can just understand and study with the real life examples. So it is all about that. So whenever in a model or a model training architecture, you will be come across the word called as ReLU. So you will understand, okay, this is the step where it is not removing any unimportant feature, it is rectifying an important feature based on our required output. So it is rectification point, like that you can understand. Okay. So, and in mathematical logic, if anyone is theoretical student present over here, for them, if you are having a set of matrix of the features, there are some negative nonlinear units. Negative nonlinear units means that kind of things, like suppose you are working on an image, you are having a set of color distribution, and this particular color you don't need, that is tending to a negative value. That kind of thing you are removing by the help of ReLU. The inner features is being removed. Right. So this is all about the important terms. Now another term I need to tell before completing the CNN or deep learning architecture. It is something, another layer present on deep learning is something called as the polling layer. So what do you mean by a polling layer, or why polling is most important? So why polling is like, why we need polling for any kind of special attention, or why, what do you mean by polling? So the logic of polling again comes into like our real life cases. That means suppose you are having a class of 60 talented students. Okay, 60 talented students. Last example we took an example of bad students, and this example we are taking an example of talented students. So you are having a class of 60 talented students. So when a teacher when to teach them, the teacher finds it is very much difficult for the single teacher to teach the 60 Einsteins, right? So what he had did, he had distributed the thing into some groups. Okay, distributed some students into some groups and individually pays the attention to each and every group, right? Likewise, we are learning machine learning. One day we had given to OpenCV, one day we had give to ML, one day we have given to deep learning. So we are learning the topics distributed fashion, in a distributed manner, right? So this is the same thing happens with the polling. Polling layer comes at the existence, under existence after ReLU. So when the model reaches a ReLU stage, that means it is removing, or it is done with rectifying all kind of features. Now whatever features the model is having, it is requiring some kind of advanced processing. That means special attention for better level feature processing, because already the feature set is something advanced. So here comes the layer of polling. Now, for your knowledge, there are three types of polling: average polling, maximal polling, and sum polling. Right? There are three types of polling. Okay, so we are done with the logics of this kind of things. So again, recapping the concepts: backward propagation when a model rectifies itself, ReLU for inner level feature processing, activation function removing the unimportant features, polling layer just to pay off some kind of individual attention to the feature sets, how this process each and every stage-wise computation, and this is a fully network convoluted architecture. So it is a very basic architecture, a very basic strategy of any neural network. If you are done with understanding, just let me know, because without jumping to the next part, I want to know like whether you guys are clear with it or not. Just shoot your thing in the chat section. Just shoot your questions or anything. If you can understand, also shoot it in the chat section. Shoot it in the chat section. If you can done with understanding, shoot it in the chat section. Or if you cannot, also you can also write. Okay, so I guess everyone is done with understanding the logics. So this is how a basic convolutional neural network architecture is. Convolutional neural network. Yeah, Arvind, I already explained the difference between AI and ML. AI though is umbrella. AI is the umbrella. So within AI, this entire things comes into existence. Okay, in MLDL, how much maths we have to cover? Nice question. So it's really very difficult to tell how much you have to cover. I can at least tell what important things you have to cover. So you need to know the very basics, at least basic of integral and differential calculus. You have to know the basics of coordinate geometry, at least how to deal with straight lines, circles, ellipse, hyperbola, parabolas. Right. Importantly, focus on the logic of your set theory and matrix. Mainly focus on set theory and matrix, because calculus basics after all you can implement. But yeah, mainly what the stage where we have to focus is the calculus and no, not calculus, matrix and set theory. Because all kind of things, like whether if there is no such algorithm that is not using at its backend, right? And if you're coming to the TensorFlow part, at least understand the vectors. But yeah, anotherly, most importantly, set theory and the matrix. Now the question comes, how much? And it actually doesn't have any definition. But yeah, for the basic neural network architectures, for a basic machine learning architectures, you need to know at least to the matrix operations, set theory operations, some basic algorithms out of it. That's it. At least you need to have the base, then you can understand the things. Like base means, what do you mean by matrix, covariance, etc. No, ResNet is in the production. Research purpose model, this advanced algorithms also have the production. Advanced algorithms, why have in a production? Remember one thing, the models which are supported by TensorFlow. What models supported by TensorFlow, ResNet, etc. are supported by TensorFlow. The models which is supported by TF is there in production. But there are some exclusive models which is only and only supported by PyTorch. Just expecting one or two, because I know one or two models which is from PyTorch also into production. That means, like, I don't know TensorFlow supports Detectron or not, but yeah, Detectron is a model which is supported by PyTorch. PyTorch also supports TrackNets, this kind of things. This kind of one or two models is there from PyTorch also into production. But yeah, the models which is not supported even by TF or any other API level platforms. So any other API level platforms, specifically being supported by PyTorch, they are not still into production. For an example, dberta. Dberta is right now launched by Microsoft. It is not in production. We also don't use BERT in natural language processing right now into production. We don't even cover the bird family. Even if you do want to do sentiment analysis, you have to go back to the initial previous model. So there are several kind of models which is only and only supported by PyTorch. Yeah, PyTorch models are specifically for the research purpose, well and obvious for research purpose. YOLO object identification is open source. Can this be used in production for production? See, production obvious. Yeah, any code is open source right now for the sake of GitHub. It's not an issue. Yeah, YOLO object detection is also open sourced. But yes, production cost is nothing like that. Production cost means, like, it completely depends upon you. Like, if you are making the machine learning model, creating your own APIs, making your own creating up to creation of any API is okay. Working in your local operating system is okay. But when you want to deploy it in any website, so suppose you are making a machine learning website. So if you want to work on that machine learning website at a minimal cost, you have to take the help from TensorFlow.js, because TensorFlow.js will be giving you inbuilt Node.js, etc. Only you have to pay for the database, right? Now, if you don't want that kind of website, complete Android app or complete desktop app or more better production, or suppose you need to have a full stack machine learning website. Full stack machine learning website means, suppose, medical operating system website, this kind, which is having a complete machine learning functionalities in it. So there only a server management platform cannot help you. So there you need to shift you have to shift for the cloud platforms. Now again, coming to the question of cloud platforms, which cloud I will be using? You will be using Azure, which you will be using GCP, you will be using AWS. So yeah, I'm just telling the good and bad of the each and every clouds. For an example, if you are going for Azure, then Azure simply if you are making for an Azure, then in the case of the Azure, there is a support of machine learning is still on the development phase. So Azure ML, we generally don't prefer. Many of the developers prefer, but we generally don't. For the GCP, instance making and instance stability is still bigger problem. And another important problem is the site security as well as the product security. Right. So now what is another most important option? Most important option of the AWS. AWS is in one word, it is amazing. AWS, SageMaker, etc. This is in one word amazing, but yeah, again the cost of the thing is more. Why? Because whenever you want to launch any model, suppose you are working a model, you have created a machine learning model at your backend, which is the size of the model is at least 3.2 GB. For an example, I'm taking some X GB, and suppose you have calculated that the runtime of the particular model is something coming 2 hours. Okay, so when you want to run the particular model on your website, that means you will be hosting your website by using a virtual machine at your backend, which is being taken from AWS EC2 instance. So you have to choose an instance to run the model, right? So this instance costing depends on how much time, how much APIs, this kind of thing. So it depends on increasing of the cost. So this is the thing. If you are thinking about production, then think, if you are generally not going for cloud for a very basic or simple project, then the production fee will be only with the database. Or at an initial model for a college purposes, making projects for the college, it's very free, very easy and free. You can even go for Firebase ML, right? But yeah, if you are working with the real-time startups working for this kind of things, so yeah, you have to take care of this kind of etc 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 logics, what I have told right now. Any other query? Because I will be not messing your brain with so much of things in deep learning, because it's again not a game of only one day. Better I will be recapping the concept today of what we have learned after some one or two examples. If you want to understand the deep etc. ML engineers, yeah, actually yes, If you yeah, actually yes, because why yes? Because uh, why yes? Just speaking from my example, first company I worked is Medv. I guess everyone can find right now. Many of the people use also Medv. It's also in the Google Play Store right now. So with that company I worked very first. So I can speak about little my experience. At a very starting, I was simply into machine learning, and I was not even knowing this kind of cloud deployment. So when I was done with giving my machine learning model, the person telling me like you have to deploy it in your cloud base. So I told like I'm not a person from cloud computing, so no, it is a work of ML developers. So it all started, and after that, in number of companies I worked, or in number of places I work, everyone is speaking about deployment. Why deployment? Because the reason I found is machine learning model, if you are simply working on Google Colab also, it is also a cloud based platform using virtual machine at its backend. Cloud is nothing, is something called connecting virtual machines, connecting hypervision, this kind of things. So yeah, so there you are also having some knowledge of cloud. So the same thing also happens in the case of AWS, as if, or you need to know cloud computing at least to how to handle these cloud platforms, like how to process the APIs, how to work with API, write your API, database connections, etc. etc. So yeah, these things you need to know, because a machine learning developer, again a developer term comes at its end. So you have to know about these several techies also. From where we study AWS? Pretty good question, because AWS, from where we study AWS, because I cannot remember the name of the site over YouTube. There is some S Swaminathan or etc. I cannot remember right now. He is signatory member also at AWS. In YouTube, there is a site. He is having some video that is yellow background. You might see in the YouTube, just search for AWS projects, and like he's a South Indian guy teaching the AWS with a YouTube yellow banner, that kind of thing. So you can refer the particular channel. It's very authentic. Rest channels I don't believe, because sometimes they doesn't speak of the authenticity. Okay, so let us complete the deep learning part, or let us finally analyze how to proceed, how you guys will be proceeding in upcoming days with the deep learning. Then finally recapping the concepts we have learned in this 4 days, and then we will be again open to queries, and just shoot as many as queries you can, because tomorrow I will be only focusing on the career opportunities and project opportunities. Right. So yeah. So now let us speak about a very simple project in machine learning. Yes. So let me open the project. Yes. We will be making a number detection project with by the help of convolutional neural networks. Right. Just a second. Let me open the project. Uh, yeah. So okay, so I am trying to make a number detection project. Number detection project means, like a very little example I right now told to you guys. That means if you are working on such a system that will be detecting a very small number, I guess many of the people used to dream, like if I can make such a system that will be detecting very small number of, suppose real time video is playing, and when the video can I make a very machine learning model that will be detecting the very small number, right, from a real time video, because this kind of things are important. Like this kind of things you can develop to detect a machine learning controlled robot security system. So that thing we tried to develop. First we collected our training data from internet as well. So first we manually labeled our data. Manually, it is MNU's dataset specifically I want to tell. Yeah, so first we manually leveled out our data for 0, 1, 2, and 3 and 5. We are simply working with this set only. We are again taking a very controlled case. So the data is in this particular format. Data is again in this particular format. So it is human gesture recognition type of data. Like human gesture recognition type of data, that means if I am like what project I'm just understand the problem statement at the very first. Suppose if you can create a very basic machine learning model, the machine learning model will can just analyze your human hand gesture. For an example, we had worked on number detection yesterday as also. So what we are only left with, we are left with human hand gesture recognition. For an example, uh, just you can understand we are deploying such a project. That means suppose we can just explain this project like this. Suppose there is anyone or any sick child, right, any very sick student or any sick someone who cannot see properly, or whose brain is not working properly, or if you need to make students analyze what is 2 and what is 3, like how we teach our students or how we teach kg students. Like we used to pose like this means 2, this is 2. So like this we used to teach. So can we create such a system that if I am posing in front of the camera, this is 2, and the camera will be automatically printing the value 2. So this kind of thing we are doing, that is hand gesture recognition. Hand gesture recognition, whatever you are facing in front of the camera, suppose you are posing for 2, it will say 2. If you are posing from 1, it will say 1. If you are posing for 5, it will say 5. If you are posing for this, it will return 1 0 10, like this. Okay, so this is, you can tell, a kg support program. So like this we have collected and manually labeled the data for 1, 2, 3, and 4, all like this. For 1, this is the class. For 2, 3, and 4, and 5, this is the manual data we had. Now first what we need to do is data collection as well as the data exploration. First we need to explore our data. So how to explore our data? is again we are exploring our data by the power of OpenCV. I guess code is properly visible to everyone. The power of the responsibility by the code by the power of OpenCV. So we are again doing what? We are simply doing import CV2 because we are importing CV2 as a package of OpenCV. NumPy for dealing the mathematical computation, because from the very first day I told like, yeah, without that we cannot do anything. OS for inputting the data. So again, what I have did first, I have simply inputted my training data and extra things. I have simply imported everything. So if there is also any real-time video feed, or if there is something called as a real-time video, so it will be captured by CV2.video capture. Then at a very first, what I am doing, I am simply inputting the image values. I am counting it in which particular section it will be falling. That means whenever there will be a real-time video feed, the real-time video feed will be going to some sort of training, and after that the output will fall in some class. In which class it will be happening. That means if you're posing for one, then one lies in which particular class that thing is being readed in the particular data. Okay. Now again, I will have to return some kind of masked value. Mask value means because our data will only analyze that kind of black and white value. For that reason, I need to analyze what amount of the section that I am posing in front of the camera. To understand the amount of the section, we need to calculate out the particular region of interest, ROI. So after calculating the ROI, what we have to do, we have to mask it. I have already told the logic of masking. It is simply changing the color values. That means thresholding the color value from the BGR to gray. The same function we are using over here for BGR to gray, and it will be obviously through a if else statement. We have to calculate if this is and this is, if this is and this is, if this is not, return this. So this is the very first logic we have written to collect data. That means for the data collection. So how this data collection will be helping for us? Suppose there is a lifetime video feed, and this lifetime video feed, the data is coming to the training script, and after the training script being processed, the data will be stored somewhere. When the data will be stored somewhere, how it will be stored? Because it is already being stored in the test data set. In the test data set, everything we can see it is a masked value. That means in a black and white particular format. So I need to first extract out the detected region by the CNN. Convolutional neural network have detected a particular region. I need to extract out that thing by the help of the logic of ROI, region of interest extraction. Then it will be masked out, and then it will be stored. First step, data collection. Next step, I have to write the logic of my convolutional neural network. I have to write the logic of my convolutional neural network. So this is not a JSON file, sorry. Yeah. Training script. So I am right now the logic of my CNN. So yeah, so before writing the logic of the CNN, I need to analyze what do you mean by keras. Right, these things are very important. Keras, TensorFlow, etc., and etc. So keras is nothing else. Again, if you need to, like you have learned about scikit-learn. So what is scikit-learn specifically? And specifically, scikit-learn is specifically a library from where we can call our machine learning models, right? Scikit-learn is a place from where we can call our ML models, right? So likewise in deep learning, at a very first case when TensorFlow vagera doesn't comes into existence, there was keras. Keras is nothing but a high level API. So I guess everyone knows how a API works. So API simply whenever you are showing some kind of request at the front end, it posts the request at the back end and fetch out the most required section out of it, right? So this is the power of Keras API. So again, at a very layman's language, Keras is something from where we call this kind of deep learning algorithms, right? So again, from the Keras models or Keras stored layer, I am calling the first important architecture of convolutional neural networks from Keras.model. So these are what are these names? Sequential, convolutional, max Poholing, flatten, and dense. These are the most important layers of any convolutional neural network. And these layers, whenever you are building your own CNN, you have to first define this layer. Wherever define this 1, 2, 3, 4, and 5 layers. You have to define these 5 layers always when you are making your own CNN, right? So what this sequential layer is all about? This sequential layer means that means just in a very layman's language you have to understand. For an example, your data is coming and being inputted at the layer number 1, then how it will be flowing to the layer number 2, and will it be flowing or not? What and if it is flowing, then what will be naming it? This is the work of the sequential layer. That means whether it will be flowing, if it is flowing and without any back propagation in a sequential format, one after another. So it's all about a sequential layer. Now comes under the convolutional 2D. What do you mean by the convolutional 2D? Important concepts in the logical terminology. So convolutional 2D. Convolutional, there are two types of CNN also present, called as the 2D CNN and 3D CNN. Not going to deeper and deeper, and hope you guys will study after this bootcamp, because another, frankly speaking, single bootcamp can give you a logic. Rest you guys have to study repeatedly and implement the concept. So convolutional 2D. Convolutional 2D is all about like yeah. So yeah, it's something like you are going to a parlor and you are trying to draw a tattoo on your hand. So how the tattoo is drawn? Suppose there is a first paper will be placed on your hand with a certain curvature which is being already marked on the paper. Then by the help of some gadget, it will be painting on the canvas or the stencil of the particular paper. Then the paper will be removed out. Maybe this is a traditional way of tattoo. I don't know much, so I am just telling about the sticker making process, right? So this is the thing. So there, what is happening in an output stage? It is giving a design on your hand, right? It is giving a design on your hand. So after, suppose, making the 7 days of tattoo, some colors will be getting faded off, and you will be getting a raw architecture of the particular design, right? Raw architecture of the particular design. So this is the work of convolutional 2D. That means if you are inputting any image, every image have a kind of raw outline, every image have kind of raw values, every image have some kind of raw interpolation. How a convolutional neural network will analyze it? This is the work of OpenCV. A complete OpenCV script is there, which used to deal with the understanding several kind of colors, understanding several kind of features out of an image. But here in the convolutional neural network, this is the work of a single layer convolutional 2D. After that, max polling, I already told the logic of max polling. Yeah, another most important layer, flatten and dense layer. I'm not going to very deep. It is all about extracting the feature one after another, like in the several image orientations and dimensions. So okay, you are done with the layer calling. So likewise, if you are making short project, every time you need to call this each and every single layer. Yeah, for the deeper projects, yeah, you have to know the complete mathematical logic of this kind of things, right? So yeah, so when you are done with that, again, likewise, I guess everyone can remember the weather prediction script. In the weather prediction script, for the prediction, we have created or for the model, we have created a particular function. Here our main motto or main trigger is sequential layer. So we are creating a classifier function for the sequential layer. So when it is done, then I will be defining my each and every single layer. This is the most important thing. Here I am not doing any kind of bigger. It is completely dependent how much layers of training you are doing. You are doing 3-layer convolutional neural network training, 2-layer training, 5-layer, 8-layer, 9-layer training. Here I am simply doing a 2-layer based training. So I will be simply defining this layer at 2 times at an activation function of the ReLU. This activation function is considered to be ReLU because it will be rectifying the amount of Munna Bhaiyas who is present in our data. Right, the Munna Bhaiyas who will be present in our data, it will be rectified by the ReLU in the convolutional neural network. Then again, it will be passed to the polling layer. I guess you guys can relate the concept I told 1 hour before. When it will be rectified, then it will be going to the polling for an individual attention. Or suppose if you cannot understand, just relate the concept. Whatever mothers used to tell us, beta, when you are going for any puja, before that, just have a wash, or just have a bath, right? Why the mothers used to tell us to bath before a puja? The logic is very simple, because our mothers know deep learning. Our mothers know deep learning. Why deep learning? Because bathing is nothing. Bathing is performing ReLU, rectified linear unit. When you are bathing, from tomorrow, when you are going to bathroom for a bath, just remember this thing. I am going to do ReLU, rectified linear unit. So when you are done, that means whatever bad things are there, it is being washed out. Similarly here, whatever unimportant or whatever the which features which are not creating problem to us, they are removed out, and then it will be passing to the very next layer for an individual attention. When you are bathed, when you are shuddh, you are going to a temple for a complete puja. So this is the work of the polling layer. God also knows about deep learning. So the same thing I know about this. It is done. Finally the last layer is being called over here. It is obviously the flattened layer, and then the dense layer is present. Okay. After calling the particular flatten function, we are passing the thing into dense by the help of a ReLU again, right? By a help of the ReLU again, and then I need to calculate what is the loss in particular CNN. That means whenever a model is learning, there might be a loss. So how to calculate the loss? There is an optimizer. I told at the very first day how to calculate the loss. This is by the help of the just optimizational techniques, and this is called as an Adam optimizer. So this Adam optimizers will be calculating at an each and every single instance of time how much loss is present in the particular CNN model training. When you are done with that, then you have to input your input data. That means whatever training data you are having in your hand, you have to input this. And when you are done with your training set of data, you have to first specify the size, specify the particular color value you will be dealing with, and whether it is classified or not. Yeah, in our case the data is a categorical data: 0 for 0, 1 for 1, 2 for 2, 3 for 3, 4 for 4, 5 for 5, right? So train data and test data is being previously classified and categorized. So yes, this will be whenever it is loaded, it is going back to the backward architecture, model training done. Finally, after model training, the thing will be saved in a format of a H5 module, model bw.h5. After the end of training will be completed, in your operating system you will be seeing something downloaded like this format: model.h5, model bw, no, sorry, yeah, model bw.h5. So now your model training is done. This is what model bw.h5 is: nothing but your weight of any CNN model weight, right? So now we have to write a single script for the prediction. So when you will be doing the prediction, all the packages you have used all over, you need to call the particular packages, then simply load the weight of the model, simply give the image you want to read, or simply give the video you want to read, what kind of categories you want to read out of it. Here I want to read 0, 1, 2, 3, 4, and 5 out of the input video. Write a simple logic. If the video is on, then yeah, script proceed. If it is not on, then obviously script will be not proceeding. Simply use the logic of ROI, because it will be not working on your complete hand, it will be working on your single portion of gesture, right? So simply on that, select the ROI, create a bounding box or rectangle out of it, because ROI is only signified by the particular rectangle. Okay, so when you are done with that, yeah, CV2 will be come under existence, and then the model is already loaded above. Now your results will be predicted: 0 for 0, 1 for 1, 2 for 2, 3 for 3. That's it. I want to show the run model. Just let me run out on Google Colab, because my webcam doesn't work, so I can show you the output of the real-time video. I'm taking any video that is having at least one number, and I'm running it. So simply what I need to run, what I need to do is run the predict.py in Google Colab. So what things I need to input is the model weight. I need to input model bw.json. I need to run a video. So yeah. So I need to run the model bw.json and model bw.h5. These two weights of the model bw.json, yeah, model h5, model bw.json, json file. Yeah, these three scripts I need, these four things I need to know. and I need to input a particular input video, right? So suppose this is my input video, I need to input it. Okay, all things are there. Let me specify the path of the input video present over here. So just a second, collab works. Yeah. So input video.mp4, copy path. Yeah. Yeah, just a second. Google, if you need to run the IM show at the Google always, this is just little snippet, though OpenCV doesn't works properly on Google Colab, but yeah, you have to just input this package always, and the lines where it is showing the IM show errors, you have to simply scroll up this line into a very little dash. Yeah, this is the line. Another line I used to use the IM show. Prediction. Yeah. These things are little changes you need to do in Google Colab. Now it will be in the text one positional arguments. Okay, just a second. Another little very basic thing. There are some technicalities on the Google Colab that we need to always follow. Just give me. It will be showing it output from the real-time video. That is here for the number is detected over here is the 01. For the 01, I guess it is clear to everyone. The number is present is over in the particular video is 01. So for the particular 01, the model is giving you an output of 1 from the real-time video. Again, the output is 1 for the next frame. Let us see the number. Yeah, it is 01, right? So yeah, let us check the model confidence 010101. So yeah, 1. Yeah, it is reading again 1 for this particular frame. So yes, our model is pretty good, working 1. 5. Let us see the output. Which one is reading 5? So I guess this one is a error. This one is an error. Okay, this thing is written to be 5. I guess it is 55. I don't know. It is 55. 4. Okay, so there is a little less accuracy. Yeah. So there is several types of number. 5. Yeah, 5 perfect. 5 perfect. 5015. Yes. 5. Let us scroll up for the another types of number. It is dividing the video in some single frames and then predicting the values. So this is the project. I guess everyone can understand this is how the projects, how I guess you guys can see the prediction list for this 5. Just go above for the one case, because one case is pretty clear. You guys can work on this project on the real-time webcam. How to work on this project on the real-time webcam? Just going back to the code script. Here the number is being predicted 1. I need to increase the text size. So if you need to work on the webcam, then just you have to remove this part. You have to remove this part and just enter 0. Simply it will be taking access of your webcam and showing your output. That's it. That's all about. Yeah. So I will be uploading the code again in the GitHub repository. Everyone got the GitHub repository, I guess, because I have provided it already yesterday. And so it's all about deep learning, implementing a very short project on deep learning and understanding what is deep learning and architecture and structure of a deep learning model. Number detection, very short project. So yes, so let us sum up everything what we have learned. So again, the sum up things is very thing like machine learning mantra. Again, remember from very stage 1, understanding what kind of problem you are dealing about. Then based on that, you have to fix up your data, you have to extract, you have to do some kind of explorations, and by the help of that explorations you have to first extract some features, understand which is the best fit model or algorithm with your problem, and apart based on that, when you are done with that, you have to train entire thing and deal with this. Machine and deep, all kind of things are very same. Supervised, when a model is working on controlled case. Unsupervised, okay, can predict for unknown as well, right? What kind of model? Linear regression, only for a prediction, y equal to mx plus c. Logistic regression, classification as well as prediction, right? It is a sigmoid curve in a fixed range. SVM, which work on a hyperplane that calculates the nearest distance, right? It is also for the prediction, detection as well as the classification. Principal component analysis only deals with the topper of the class. The most important component controls the output. And decision tree classifier, it's all about the father or the head of the family who used to take the decision, but yeah, his decision is controlled by several family members, several family members, multi-parametric output of prediction as well the classification, right? And what we have learned more, we have learned more about OpenCV. Through OpenCV you can do several types of image processing, amazing projects, because it is all about computer vision, cropping an image, resizing an image, blurring an image, etc., etc. We have learned about convolutional neural networks. So in the convolutional neural networks, you have to do what? Whenever you are coming to any deep learning models, in the case of the particular deep learning models, you have to do a neural network based architecture, right? In that particular neural network architecture, there is a layer wise training, there is a layer wise model training. Always you have to work on the feature analysis part, you have to extract the most important features, and that's all about deep learning. So I will be telling from next day, tomorrow last day, about how just you have to go and how you have to proceed with everything, right? So yes, so now tomorrow is the last query part. So yeah, now I am getting back to the query section. If you have any query, just shoot it out one after another. Tomorrow we'll be dealing with some kind of careers and careers part, most project ideas, and just some other important logics and important resume making for a machine learning things as well. Tomorrow we'll be dealing with that kind of thing. So it's all about today. Hope you have enjoyed the machine learning models, and tomorrow is for all about the career parts. So yes, now open to query. So any type of query or what kind of queries you guys are having, you guys can feel free to shoot. Any type of query you guys can tell.
Guys, any queries? Can you tell?
Polling is very polling is something like if you have a class of 70 talented students, and out of that particular 70 talented students, the teacher alone cannot handle that kind of 70 students. So to handle the 70 students, the teacher have to pay individual attention. So it breaks up the students into some groups to pay some kind of individual attention, because the 70 students are the purified students, and out of the 70 students he want to again select some more purified student, maybe it is 50 students, and to understand in between the mass of the talented students, you need to break up the person into some groups, and out of that particular groups you have to pay the individual attention to each and everyone, right? So this is all about polling. There are three types of polling: max polling, sum polling, and average polling. The question is, sir, can you tell about some details of what type of code we need for the self-driving? Okay. What? Okay, acha, self-driving. Yes, self-driven car, or yeah, brain-driven car. Yeah. Okay. Yes. So specifically, see, for the self-driven car, it's something like though it is in a very object, very in a research stage right now still, because many of the companies have launched product, but still it is not into production. But yeah, if you want to create that kind of things, so the three things you need to take tackle in your mind. One is your model should have the capability to understand or judge the angles, because a road is a complexities of some sort of angle. So your model should have the probability to understand an angular vision. The very second thing is object detection, a very high level object detection. It's not like our model is something detecting a very near object and cannot detect a far object. Because remember one thing, our human eye can detect both far and near objects, right? So the second thing your model should have, that is the object detection. And a very third thing is the color analysis, color recognition, because signals will have some sort of color, and like color and sign analysis, because sometimes traffic police also told like this, that means stop, right? If anyone told like this, that means stop. So you have to write a code for a gesture recognition and color for the traffic signal, gesture for analyze the signals like this. These are the very four things. One is for the gesture, for this hand controlled works. Second thing is the color. Third thing, color and number as if. And third thing is the you have to understand object detection, and the fourth and most important thing is angle detection, angular detection. So you have, whenever you are creating any deep learning model or maybe any other model, whatever architecture you are following, you or any computer vision architectures, you need in your logic making system, maybe it is in the feature processing or in a training stage, you need to take care of my model should have the capability, just a little architecture, because in a single model we cannot do this kind of thing. So you have to see, either you have to create a separated architecture for these four models and then integrate it finally based on each other's log. So this kind of code you have to write. How can we teachable machine? Teachable machine learning means the Google site you are telling others. The Google site, I guess there is a site teachable machine learning. That site, that site you are asking all about, or auto coding something like this. Teachable machine, just explain. Is FaceNet like? अच्छा, okay, got your question, yes. So how can we use teachable machine? Teachable machine in a better way. Yes, I got your question. Yes, okay. So better way means like you have to. It completely depends on like Alex. Alex is though a very old. Alex is not old. Sorry, ResNet is actually old, right? Like so specifically, yeah, not road margin, yeah, margin detection again a logic. So this kind of things. Yeah. So coming back to this particular query, like. This is a very difficult question to analyze, like how we can model how of that model. So teachable machine means like teachable machine like AlexNet, ResNet. Yeah, these are the computer vision projects, computer vision models, right? So specifically computer vision algorithm. So teachable machine means like what is the perfect question of the teachable machine? Can you just little bit of explain it? Cannot get the question properly. AlexNet, ResNet is okay working on the computer vision advanced models. So just write your query. Just I am handling another query. Whenever a new ML problem is placed, what are factors to be considered from technology perspective? Very good question. Yeah. So yeah, whenever a new machine learning problem or algorithm, two factors are different. If you are speaking about a machine learning problem, for an example, the most important problem of the COVID-19 time is the online teaching. So that is not only for machine learning, that is for any case, that is online teaching. So during this online teaching, the major important problem is cheating. Like students used to keep on cheating behind the scenes. So how it will detect, because we don't have that kind of advanced facial recognition technique, frankly speaking. 100 times we speak, our research is very developed, these things are very developed. Frankly speaking, from a real life example, we are still standing on a stage of MNS detection in a production level. I'm speaking for an industrial level or its production level, because still in Google, if we are going to deploy in Google models as well, so Google models as well, then we are also using some kind of dat models at a backend. So at a production level, we are still in background. So I will be speaking about a ML problem at a production level. So when you are trying to solve an ML problem, so the first thing, yeah, any new ML project, yeah. So what I am telling about the COVID-19 ML project, that is the cheating, even to track the cheating. So first thing, whenever you are dealing with this kind of project, suppose in medical domain, educational domain, first again you have to understand the domain and what are the previous approaches. The first work will be understanding what I am trying to do and what are the previous approaches. So many of the people for previous approaches keep on asking its friends, fellows and seniors. Some of the people refers the research papers, that up to you. But yeah, again, if you are working on the research paper, then please and please work for or study for study research paper from IEEE Scopus and Springer or SCI, right, Science Direct. Because we also, like, in some there was a project I was working on, and there very less research paper was present on that, right? Like very less research paper on that. Just I was using any kind of XYZ research paper, and the outputs were really miserable. So don't rely on any other papers, only these good papers. So you're studying some kind of this research papers. So in this particular research papers, you'll be finding the previous approach. So when you are done with done with that particular previous approaches, now you are clear, okay, this kind of work is done. Now you have to first write up your own algorithm. For an example, you are creating a facial recognition model to detect the students cheating. So what is the first thing that comes in your mind is like, okay, can I recognize the face? So there might be categories or characterizations of your face recognition, right? Characterizations of your face recognition. So what are these particular characterizations or how to detect it? So initially, to cheat, how to detect the cheating is to check the user's eye. So obviously your model is that norm that you cannot create such kind of ML problem or ML model that can detect the eye movements at so proper level, production level. So you can detect this kind of facial movement, right? So you have created a machine learning model, very easy CNN facial recognition at a production level, which is detecting the facial movement and returning you a log file, dot log file or a JSON file, that is having the amount of the time a user have moved left, amount of the time right, amount of the time up and down, and amount of the time the user have been straight. So a list is returned. So in the returned list, you have to use a k-means algorithm or a KNN algorithm to check which is the most valued thing in the list. That means, suppose you have to think like this, think step by step. Like, okay, by the power of k-means, by the power of any clustering, I can tell which action the user have did during the thing at a most amount. For an example, the return is left. So it is a general logic. If the user is facing front and the user is not doing any sort of cheating, for an example, a dummy case. But if it is moving for turning for left, yeah, he is seeing something left that is out of the bounds, right? So yeah, the returning product, and it will be showing the output that the user is cheating. In this way, you have to develop your models, develop your logics, algorithms, and a new ML problem comes into existence. This is the way how we solve. Next question. What can the teachable machines do basically? Teachable machines, teachable machines is specifically, there are two things that comes in my mind by teachable machines. I am telling the two answers. One is the Google teachable machine learning site. The Google teachable machine learning site is doing nothing. It is specifically machine learning for all. That means if you don't know a single line of code and you want to show a output by machine learning, you can go to that site. You can record your video and enjoy the power of machine learning. That is teachable machine learning. Another important thing that comes, that is teachable machine, maybe is the auto learning process. I guess you are maybe thinking about reinforcement learning. It is not teachable. It is called reinforcement, where a model can learn by itself. So specifically, reinforcement learning is also not in a production stage. It is again in a research stage. It's specifically taking again a reference from the previous features that is present on a model and showing it in the output. That's it. So yeah, so the next question is, sir, give me some tips for how to learn for beginners, not for copy answers or only stuff. I mean, originally some of coders can write code. Yeah, all coders and developers. Coder to developer, yeah, same thing. Developers, yeah. I will not tell all developers write their code by own, but yeah, they write. Yes. So this question is a single line answer of this question, because is you have to make logic, because coding, to me coding is all about code. If you simply speak about code, then code is a language. Likewise, I am talking to you guys in English, so our mode of understanding is English, and I know how to speak English. That's the thing. So this is if you know how to code, that means you know a language and you know how to speak with computer. That's it. That doesn't mean you grow logic. Logics, if you grow logic, then rest is the language learning. So what I tried in the entire session is to make that logics. That's it. That, I guess, this is the best way to for me to answer. And is Cassandra essential if we can make web pages and the web development frameworks? Essential, though we don't use in so much of like so much frequently. We don't use it right now, but yeah, if you are learning, it's well. Yeah, thank you, thank you. I mean, not Stack Overflow. So Stack Overflow, I guess everyone have to take help from Stack Overflow, because Stack Overflow has become something that we cannot remove up, or we cannot leave independently without Stack Overflow. But yeah, sometimes what happens, there are some problems. So if you want to code really, then try contributing on open source, because in open source, if you are working suppose in TensorFlow issue section, then you will be, or suppose for an example, in any open source repository of any company, will be having some examples which is not yet solved, and you will have the privilege to solve that kind of things. That's it. Should we use MongoDB or MySQL for web development backend? Web development, I will be not, I am not so much sound on web actually, but yeah, I can only speak about, if you are working on just from little experience, Mongo. Right. How can we implement reinforcement algorithm through OpenAI? Very good question here. So if you are working for any concepts of OpenAI, that OpenAI or the fast AI, basically OpenAI use the logic of the fast AI at the backend. For if you're going for reinforcement learning, then you have to take the help from the advanced transformers. Right. This is very advanced techniques, and actually you can to help the use of autoencoders. You have to take the help from encoder mechanism. You have to take the help from transformer based learning. So this kind of things will be helping, right? For a new ML project, uh, who how would decide about the technologies to be used, architect or predicted client or SM, etc.? Who okay, okay, what kind of technologies you will be using? Completely developed. See, one thing I want to tell, just if you are speaking all about the developer's point of view and industrial point of view. So there are two point of views. Industrial point of view, again, two different things. One is complete a big MNC, not speaking only for a product based company, or suppose divided into product based and consultancy. Right, two things: product based and consultancy. So if you're in a product based company, a developer is the last one to speak, right? Because developers is considered to be something supreme, anything like that, right? So yeah, architect can make the things. Architect can make the things like step by step how the things are implemented. But which I will be using, which tech stack I will be using. So if you are a developer, that's your duty. Architect will be framing it, framing and step of an algorithm. That means simply. And consultancies, I don't know, because I don't have any experiences with that kind of companies. Yeah, I can only speak about product based companies. So yeah, in the product based companies, if you're a developer, then you have to know this kind of thing, because because whenever you are appearing for any interview of product based companies, they will be asking you, if I am giving you this kind of problem, how to plan the steps. So this kind of things are there. I will be telling about company opportunities tomorrow, don't worry. For DevOps particularly, which technologies to learn? DevOps, yeah. For the DevOps, you need to go for DevOps, you need to go for specifically. I tell, stop using any kind of like, if you are using still on Anaconda, stop using that. If you are still on stick only and only to VS Code, stop using that. First, go and install Vim. Very few students, very few DevOps engineer go for Vim. First thing, Vim. Second thing is that you have to know Docker, you have to know Kubernetes, you have to know virtual machines. So third thing is that You have to know Circle CI as well as the several kind of CI/CD frameworks. Fourth most important thing, at least know the developers framework like Jest, like TypeScript, this kind of things. Facebook Jest framework. So this kind of frameworks, concentrate on the language-based frameworks. Suppose you are going for Python DevOps, Python Ops, then go for Python-based language frameworks. So these are the journeys of the DevOps. And otherwise, yeah, you can contribute like Jenkins, etc., over there. That's up to your choice. But the most important thing is Docker, at least Vim, at least frameworks of a particular specific language. Is ML useful? Cybersecurity, ethical hacking. Yeah, ML is being used because my even start of journey is from ethical, like not ethical hacker, but yeah, in cybersecurity field. Even my first work was cybersecurity. So specifically, most of the even inter country wise, because I want to specifically tell the example of some big companies like Nvidia, Stellar, InfoStellar, right? They are also working on deep learning models to detect the cyber crimes over internet. They're using the deep learning model to detect what will be the next probable attack. They detect the cyber injections, how if anyone is doing any kind of injections over the web, how to detect as well as to stop that. This kind of things is being powerful. So what you can work on the cybersecurity industry is about the development. Like in the developer's point of view is to detect it. Please tell your journey of learning ML. Well, my journey is all about like because I started like, yeah, my journey about machine learning is I started with a very basic idea because I was coming from PCMB background, right? So coming from a PCMB background, having a biology all over the life. So no, well, like I didn't have any like connection with the coding at after a certain time, right? So specifically when I was coming, I was trying to find something supernatural into naturality because I was a dreamer, right? Because I love to paint and love to sing. Because for that reason, I was trying to make something that will be bringing my dreams into reality. I simply scraped out over internet and find something called artificial intelligence, and found the requirements and just like, oh my god. So I very basically started with the coding languages again, C, Java, Python, right? This kind of C, Java, Python. Then again, yeah, what I mostly focused in machine learning, I started with very basic models, create a planning of a week, keep on studying several kind of papers, keep on studying several mainly papers over the internet, devoted time to develop short project, participated on the hackathons, right? Participated on a hackathons and tried to understand the logics mainly. Than that of the coding part, first logic, then implementation. So this is how I start. I will be telling tomorrow more. For DL is RNN. Yeah, RNN is a part of deep learning. Na? It's a neural network as if. It's a neural network. RNN, LSTMs, this all are the part of the neural network. So yeah, it is part actually. Essentially, it is up to use. It's up to you which one you want to use. But yeah, again, it's a part. So you have to know this because RNN is even very much effective for segmentation processes. If you are working on natural language processing and computer vision, RNN based LSTM implementations are mostly important. Any other query? Lots of query today. No query. Any other query?
Any other query, guys? Okay. Sir, I don't think we have a query.
Yeah, for ML feature engineering, yes. For feature engineering, the terms itself speaks like you have to go for the features first because whenever you are working on a model training and we have to train your model and test your model or predict anything, you have to work on the features and the parameters based on which you want to test, right? So yeah, feature is important. Feature selection, feature understanding, processing of each and everything is most important. So I guess we are done.
Yes, sir, I guess we are done. We don't have any more queries. So thank you so much, sir, for this session. It was very informative, and I hope that everyone enjoyed it too. And yeah, guys, tomorrow is the last day of boot camp. So I request you all to be there like exactly at 7 p.m. Please join us so that we can start, with our session as soon as possible. And so we have one more query. Oh, sorry guys, he's gone. So we will try to cover it up tomorrow. And thank you so much. We have the links given in the description box, our Instagram handles and LinkedIn. In the upcoming session, in future, we'll be having more sessions on data science and deep learning. So stay connected with us and thank you so much. We will try to cover up the last query tomorrow. Thank you.